Hello! In this video, I'm going to show you 5 different leaks which I found in 5 different properties. I'm going to show you in detail how I go about fixing each of these joints, things to watch out for, things to do to make sure that when you fix your own leaks, you don't get any problems. Each leak is a completely different scenario, although the first 2 are very similar in that one is on central heating system and the other is on gas pipework, but they both involve solder joints not being soldered correctly. The third leak is gas pipework again, where it incorrectly used fittings causing a leak. The 5th leak involves plastic pipework, and this is a very unusual leak. And the final leak, I want you guys to have a guess at what the problems actually were. Again, quite an unusual leak, but I can see how it can happen, or maybe it was just put together by cowboy plumbers. So stick around to the end of the video to see what those problems actually were. Now this video is a follow-up to my last video all about leaks, and if you want to watch that video, you'll find it in the cards above now or down in the description. Down in the description, you'll find lots of other help videos which are made to help you with your gas boilers and your central heating. From how to replace a leaking radiator valve without draining your system, to installing smart controls so you can control your central heating from your smartphone, and generally just everything you need to know to make your central heating system run as efficiently as possible. Right, now let's get on with showing you how I go about repairing these leaks. Now this bit of pipework is joined onto the radiator, which you can see just to the left of me. Now I've pulled back the carpet and the underlay and I've taken up a few boards, and now I can see the leak underneath the floor here. Now the homeowner has used some silicone sealant, slapped it all over the fitting there and tried to stop the leak that way. But obviously, as I would expect, it's not worked and the pipe is still leaking. Now the best thing to do with any solder joint which has started leaking is just to start again, so I'm going to cut that whole section out there and replace the whole lot. So I found a convenient spot to cut through the pipe just a little bit further along so I can attach a new piece of pipe nice and easily. Now when I moved the pipe so I could cut through it, my pipe slice, this joint here started leaking even more. Now take a look at this. I've cut through that 15mm pipe a bit further along, and look what happens when I lift that pipe up and I give it a wiggle. The 15mm elbow on top moves about inside the 15mm elbow underneath, which means that the soldered fitting has never soldered properly, or the plumber who fitted it originally forgot to solder the fitting. And the flux that would have been used has actually been sealing the joint for years and years and years. And there you go, look, I pulled it completely off. You can see a little bit of solder just there, and on the other side there's a teeny tiny little ring. You might be thinking this is just a one-off, but I've seen this many times. Now this is on a combination boiler system, and I don't need to drain the whole system down to repair this joint. Obviously, not needing to drain the whole system down can save you hours of time. So I'm going to explain to you the process which I do to get to the stage I'm at now. So the first thing that I'm going to do is to turn off the power to the central heating system. So I switch off the main switch, and that's going to ensure that nothing's going to start running when I'm working on the system. If it's a pressurized system, I'll sometimes isolate the boiler by closing the flow and return valves. But this isn't necessary. And on a traditional system where you have that hot water tank and loft tanks, I still wouldn't drain this system down. What I would do is I would bung up the loft tank. That creates a sealed system and an airlock, so you can work on the system without having to drain the whole system down. And of course, if you want to know about how to go about bunging up your loft tank so you can work on your system without needing to drain it down, I made a video showing you the best way to go about doing that. The next thing I need to do is to remove the pressure from the system. And this applies to any system that you may have. The easiest way to go about doing that is go to a bleed valve, open it up and catch the water coming out until no more water comes out. Now this may take some time because you'll probably need to drain a couple of pints of water. So a quicker method is to close both of the radiator valves and then open the bleed valve and let the pressure out of the radiator. With both radiator valves still closed and the pressure removed from the radiator, I can then undo the nut that joins the radiator valve onto the radiator. So I use 2 adjustable spanners, support the radiator valve and undo the nut holding the valve onto the radiator. I'm going to get some more water dripping out as I undo that nut. Depending how much movement is on the radiator valve, I'll sometimes loosen the nut on the pipework. I can then rotate the valve around, bung up that dripping radiator with a bit of kitchen roll. Do not use toilet roll because it breaks up and falls apart. And all the time I'm doing this, you can see I've got my water vacuum running and it's sucking up the water which is dripping out of that radiator valve. I can then nip that nut back up again. Then I could either use my water vacuum or I could attach a hose pipe onto the radiator valve, and then I can open up the radiator valve and drop the pressure on the system to create an airlock. Now, depending on your system, you might need to close more radiator valves around your house to stop water from continuously dripping out of your pipe that you're trying to repair. And there you can see I can now remove all the pressure from the system. And then as long as I always keep one pipe capped off or one radiator valve closed, I will have created an airlock and water shouldn't come out of the pipe I'm working on. But always be on guard because water does sometimes come out. And of course, not needing to drain the system down will save you hours of time. But if you do decide you need to drain your system down, of course, I made a couple of videos on how to go about doing that, with and without using a drain valve. And I very rarely use a drain valve because they're fraught with all sorts of problems, which I go through in the videos. Now let's get back to fixing that joint. So now you can see that I've cut out all the pipe work. I've cleaned the old copper pipe up with some emery and I'm ready to start adding some fittings. You can see that I've cleaned the other end up and I've applied some flux to it, and I've got a new bit of copper pipe with a 15mm coupling on. Slide the new bit of pipe onto the old bit and I'm ready to solder the fitting. So I'm just going to raise this pipe up with a bit of 15mm tube, and I'm going to put another bit of copper at the other end, making sure that the pipe stays straight and the fitting's not under any strain. I can then solder up the fitting. Heat the fitting up, and I think that's about the right temperature, and now I can apply some solder. And as usual, there goes the good old smoke alarm. Solder one side and then I solder the other side. Add a little bit more to the other side, and then you'll see a nice drip of solder come underneath, so there's plenty of solder in there. And then just knock off any solder drips. Wait for it to cool a bit and then I'll wipe it down with a damp cloth. Now I've cut and prepared a little bit of pipe work for the other end. Now what I want to show you here is I need to use 2 elbows. One's going to be a standard elbow and the other one is going to be a street elbow. A street elbow is a fitting where one side is a standard pipe size, so it can be fitted into another fitting. Now I've put a standard elbow on the bottom and then the street elbow on top. Now I could fit them the other way around with the street elbow on the bottom, but fitting it this way around means that when I solder the fitting up, the solder runs down into the fitting. Rather than if they were the other way around, then the solder has to be drawn up into the fitting. This is the better way to do it to ensure I don't get any leaks. Now I just solder these couple of fittings up and then we're all good. There's no more leak. Now what I haven't shown you on this video is at the other end of this pipe, it is joined onto the radiator valve. And what I've done is I've disconnected that pipe from the radiator valve because, like I said before, as I heat the pipe up, the air is going to expand and it needs to escape. Otherwise it's going to blow the solder out, making the joints leak. Now you can see me applying the solder to that street joint and you can see the solder nicely running around the fitting. Apply it to the top. And again, you've got a nice strip there. And what you can't see is the solder that I applied to the elbow on the bottom has run through the elbow and come out the other side. So I only need to add a little bit of solder to that joint and it's all done. Now you might also be thinking I'm heating up the pipe right next to it, but that pipe is full of water and there's no chance that that solder joint is going to come undone. Now if there was a gas pipe next to it, then that would be of concern. And I wouldn't want to be heating up a gas pipe. After taking a look with the inspection mirror, I decided to add a little bit more solder to that bottom fitting. And there we go, that's all finished. Now I'm just going to clean the joints up with a damp cloth. Wipe all the joints down and then have a look with the inspection mirror and make sure that I'm happy with all the joints. There's a nice solder ring and a good drip of solder, so I'm happy with all the joints. Now all I need to do is to reconnect the pipe onto the radiator valve, fill the system with water and check for leaks, but I am 100% sure that none of these joints will be leaking. Now I just wanted to stress that it is really important to make sure there is no water in the pipework or there's no water dripping out of the pipework, because you cannot solder with water in the pipe. The copper just doesn't get hot enough and you won't get that solder flowing around the joint. Now if you do manage to solder a joint where you've got some water in it, the solder might be all blobby and it may not leak straight away, but it might well do in the future. Now you can see I've been applying flux to all the joints, and of course you must apply flux, otherwise the joints just will not solder. And you don't need to be putting a massive blob on like that, because that's just going to run down inside the pipework, which is not at all good for your system. So I'll clean that big blob off. And the other thing which is really important is you can't solder if both ends of the pipe are sealed up. So you always got to have one end of the pipe open, or maybe if it's on a radiator you can have the bleed valve open so expanding air can escape. Otherwise, as you heat the pipe up, the air inside it is going to expand, and if it can't escape, it's going to go out through the joint which you're trying to solder and blow out any solder, and of course causing a leak. Or as the pipe cools, it'll draw air in through the joint again, making a leak on the fitting. But on this bit of pipework that I'm repairing, there's a drain valve and the expanding air can escape through that. Now these video clips regarding this leak come from the other video all about leaks. And I go into more detail about preparing your pipework and what you need to do to make sure you get a really good solder joint. Now let's take a look at a really scary bit of pipework which I came across. Now a customer asked me to replace the hob for them. And you can see the old bit of pipework there, which was behind a wooden panel. Now, what was scary about this is I was taking a look before I started working. I just moved the pipe around thinking, where does this pipe go? And then all of a sudden, one of the copper fittings came apart and there was gas pumping out behind the cabinet. I could hear it coming out and I could feel the pipe was completely loose. So then it was a bit of a mad rush to find the gas meter, find the handle and close the gas valve. And you can see there is no solder down inside this fitting at all. Although you can see in the cupboard there's a burn mark on the wall where someone has tried to solder it up. But the customer told me that this has been here for about 40 years and there's never been any smell of gas. And like I said, I was literally just taking a look before I started doing any work. So this homeowner was really lucky that this bit of pipework stayed together and didn't just suddenly burst apart, filling her house with gas. And here's her nice new hob with a nice bit of new pipework. Here's another gas hob. Now I was called to this property because the homeowner said they could smell gas in their kitchen. So on investigation, I took out the oven and then what do we find? This is my gas sniffer and it's sniffing for gas. And there, look, you can hear it's going crazy now because it can smell gas coming out of that joint. So it was quite easy to take that bit of pipework out. And what I found was that the fitting here wasn't even tight. Look, I turn it and it just turns around. And it seems that whoever put it together, Mr. Bodgett and Scarpa, had just tried sealing it up with a bit of joining compound. And that is not the way this type of fitting should be sealed. So if I take that elbow out, you can see in the bottom of the fitting there is a fibre washer, but it's just not done up tight enough to sit down on it correctly. And that's because he's used a solder fitting, which has to be in exactly the right place when it's soldered up. And of course, this one wasn't. So the way to get around that issue is to remove the old fitting and use a compression fitting instead. This is still classified as an accessible area, so it's okay to use a compression fitting. And you can see the gas isolation valve also uses compression fittings, along with a connection actually onto the hob itself. Now with this type of fitting, there should be a fibre washer which seals the elbow onto the fitting. Now what I'm doing with this black tape on the cooker elbow is I'm trying to work out whether the elbow is actually screwing down onto the fibre washer, because the threads inside the fitting don't go all the way down to the bottom. If you're a new gas engineer, be careful with these type of joints because of the way they're manufactured. Sometimes you can do them up. It feels like it's gone tight, but actually the threads aren't long enough and you still don't get a seal onto that fibre washer. So use a different fitting and make sure that that fibre washer is properly compressed down onto the elbow. And here you can see the fibre washer compressed in between the two fittings. Then I put it all back together and I use my gas sniffer and have a good old sniff around and make sure that nothing I've taken apart is leaking. So as you can see, my gas detector is beeping away happily, showing me that there is no leaks. So a good job done. Now sometimes solder joints just don't solder correctly. It can happen to anyone. You can have a really nice shiny pipe, lovely clean fitting, flux on everything, and still it doesn't quite solder properly. The solder doesn't run around the joint correctly, and then you end up with a pipe like this, where many years later it can start leaking. So it's not necessarily anyone's fault, it can just happen. So here you can see there's solder all the way around on one side, but when we look on the other side, there's no solder at all, just a little tiny bit at the top. It's always best just to take the joint apart and start again, because of course you don't know what the inside of the fitting looks like. Now here's another leak. Can you guess what's been going on here? You can see the water coming out of that bit of plastic pipework. If I follow the pipes back around, you can see it connects onto some copper pipes just there. Now this is for a central heating system. It's the flow and return from a radiator. Now take a look around and what can we see here? Yes, that's exactly what you think it is. Some little rodent has been chewing away on the plastic pipes and they've chewed through and now we've got water coming out. Dropping the pressure on this system and obviously water then dripping through the ceiling. Now this is on a combination boiler, so once the pressure has gone, no more water will be dripping out of that joint. Unlike a traditional system where the water would just continuously keep coming out as the header tank in the loft just keeps on the refilling. Once again, there's no need to drain the system down. As long as I keep one end of the pipe capped off, water shouldn't start coming out. So I'm going to replace the elbow on the copper pipe and that whole bit of pipe work right the way around. And there's a new bit of pipe work, all fitted and leak free. Now I believe it's pretty unusual for mice to chew through the pipes, but look here, that bit of poo there is a lot bigger than all the other pieces. So is that a rat, a squirrel? Something a lot bigger than a mouse actually chewed through this pipe. And this is underneath a bedroom floor. Before I show you the last leak, I want to quickly introduce myself. My name is Mark Ballard and I've been a gas registered engineer for over 30 years. The aim of my channel is to help you with your gas boilers and your central heating. If you find this video at all useful, then please give me a little bit of feedback by clicking on the old thumbs up and subscribe. That will help others to find the video and of course share it with anyone else who may be interested. If you visit my website, I've categorized all my videos and products and parts that I recommend so you can easily find what you're looking for. And if you fancy getting yourself a DIY t-shirt or maybe a mug, then check out the shop below. And I'd like to say a really big thank you to everybody who's bought me a cup of coffee and left me a donation in my Toolbox fund. It's really appreciated and it does really help me to make more videos which will hopefully help you. Now this is a bit of an unusual leak and something you should definitely be aware of if you do plumbing work. And unfortunately this is another cowboy plumber. Now this little old lady gave me a call in the morning telling me that her central heating had not come on in the morning. So what's going on here then? So here's the combination boiler. You can see the hot water is running. You see the hot water tap is on and the boiler is firing up. And yet there are no hot taps turned on in this property. So they had no central heating. So that's how we found the leak. So we come around here, open, pulling the bathroom apart. See the floorboards there. And down here, you can hear the water coming out. Down here. There is the pipe. You see the steam coming out from down here. Look at that. So sometime during the night, this fitting has burst apart. Obviously, this is a hot water pipe, and a combination boiler only runs one thing at a time, and the hot water always takes priority over the central heating. So this is just like having a hot water tap turned on. So can any of you plumbers out there guess as to exactly what's happened here? Now it does look like this fitting here hasn't quite been screwed up tight, although that isn't the reason why the pipe has burst off. Now this is quite an old property, and what can you sometimes find in old properties? To be honest, it didn't click on me straight away because I didn't think anyone would be so stupid as to do what they've done. Now here's a handy little tip for you. If you have a Valiant boiler with a filling loop underneath it like this, you've got these two little handles, and if we open this valve here, like we're going to top the central heating system up, that will turn off your hot water. Make sure this valve here is closed, otherwise you'll start topping up your central heating system, and you don't want to be doing that. But with a valve like this, it will turn off your hot water. Now I could use this little isolation valve here, but you can see there's a lot of green around it, and if I close that, it might start leaking. So I don't want to touch that one if I can help it. I can demonstrate that quite easily. If I just open that valve back up again or close it, you'll see the hot water symbol reappear and the boiler fires up. That's because that water is still pouring out underneath the floor. Now I am wondering what could have gone wrong here, because these don't usually pop off. I find these are pretty reliable, but something has obviously gone wrong and it's caused this fitting to burst apart. Now like I said, these screw on and off, and when you've finished doing the fitting, when you push the pipe on, you then do these up tight, and then that kind of locks this into position, so it like clamps it down onto the pipe. And what I'm guessing is because this was slightly open, it's not fully locked, and so it then allowed the pipe to burst off, but it shouldn't burst off anyway. Well, it turns out that there's two things going on here. As soon as I undo this fitting on this T, you'll see exactly what the problem was. We can take a look inside here and see what's happened. So there's our fitting. Oh, what's going on there? There's a hole. There's a hole in the pipe. What the? It looks like the fitting's not failed at all. There's a hole in the pipe. What the? What? Why? Is that a hole? Is that really a hole? It looks like a hole. So I've got a piece of copper wire, and I'm going to see if I can just poke that in there. And you'll see it goes straight in. What? There's a massive hole in this pipe. Now that is pretty unusual, but I have seen it before. Obviously it would have started with a little pinhole, and then gradually the water actually wears the copper away and the hole gets bigger to the extent where it was now. This could have been going on for months until it reached a stage where it actually brought the boiler on, where there's so much water flow. But this isn't the only problem with this copper pipe. Has anyone guessed it yet? And no, it's not because there's a whole load of paint all over this pipe. So that means that this bit of pipe has come from somewhere inside the house, and then they've used that old bit of pipe. That may be because 22mm copper tube is really expensive. It's around £7 a metre right now. So here's that little bit of copper tube, and here's that hole, which I think is sat right where the O-ring would be. And if we look inside the pipe, can't see anything particularly wrong with it. It's just a hole in it. Now at this point in time, it still hadn't clicked at what the next issue actually was. So I'm going to cut this bit of 22mm copper tube off. And because we've got push fit fittings, I need to make sure that the end of the pipe is nicely rounded over. So that's why I use a pipe slice here to do that. So when you use a pipe slice, you push it onto the pipe, you twist it around, and then when it finishes cutting, you get a nice rounded edge like this. This allows the O-ring inside the fitting to slip onto the pipe nice and easily. What you don't want is the pipe to have a square flat end like this. We got lots of little burrs going all the way around because this is the end of the tube, or you've cut it off with a hacksaw, because then when you push the fitting on, it's going to scrape and damage the O-ring. It may not leak straight away, but it might well do in the future. Now I'm just demonstrating here how you can push a grab ring off a piece of copper pipe. Now when I pushed it down, it slid down a pipe really easily. That's what I realized what the second issue was. Have you guessed it? Yep, it's old 3/4 imperial tube. Now this is a 22mm coupling, and that should be a tightish fit onto here. Let's see how tight that is. No, it just drops straight the way through. That is a 3/4, an old imperial 3/4 of an inch pipe. So before we switched to using metric, we used to use old imperial size copper tube. So this is 3/4 of an inch. And for a very long time now, we've been using 22mm tube. And the size difference between 22mm and 3/4 of an inch is 0.95 of a millimeter. So pretty much 1mm. So you must not use old 3/4 pipe in a 22mm fitting. It's going to be loose and most likely leak. Now we can get special fittings which reduce 22mm to 3/4. You can actually see it stamped on the coupling there. So this will slide onto here nice and tight like that. And the old imperial pipe will slot into that nice and tight as well. And then you can make a good solder fitting onto that old imperial pipe. Putting 22mm push fit fittings onto old imperial pipe is not going to work at all, and there's a good chance they may burst off or start leaking. So now I need to remove that 22mm coupling and replace it with a 3/4 solder coupling. Now I thought I'd just mention you must not use compression fittings underneath floors. It contravenes the building regulations. Compression fittings can be used on imperial pipework if you use a special 3/4 of an inch olive. And I cover everything you need to know about compression fittings in my video, how to use compression fittings. So that's it. So if I turn this tap on, again, get some water coming out. Then we can just turn that back off again and then check all my fittings. So there we go, I've now replaced all the bits of copper tube which were incorrectly sized. So all the SpeedFit fittings now have the correct size tube inside them, so they're not going to be bursting apart. So that's the bathroom all put back together again now. Actually now has hot water and no leak. Right, now I hope this video has helped you gain a little bit of knowledge into how to go about fixing your leaks. Now if you want to watch my other video all about leaks, you can click on the link just there. If you want to know how to replace a radiator valve without draining system, then click on that link just there. And of course, as usual, please give me the old thumbs up, click on the subscribe, share it with anyone else who you think would be interested, and a cup of coffee in my toolbox fund is always really appreciated. Bye for now, and I hope to see you in the next video.